This could be one of the easiest but most foundational lessons for trigonometry. I'm telling you, this is so important. When we get into the unit circle, this still is going to come into play. As we get into the more complicated things, this always comes back to the trig ratios. This is the foundation here. And you probably have heard the three words before, being that this is pre-calc, but SOHCAHTOA is our way of remembering these three trig ratios, right? So what does SO mean? It means sine is opposite over hypotenuse. What does CA mean? That cosine is adjacent over hypotenuse. Please don't say sin or cos. That is not. It's sine and cosine. Just shows me that you're not paying attention at all whenever you say sin and cos. Sine and cosine. And then tangent is opposite over adjacent. All right, now what does that even mean? And we took a look last lesson. Well, opposite. So if this is your reference angle, we call this theta, by the way. Usually we use theta for the angles. I think in this con assignment they're using beta, just some Greek letters there. So opposite of theta, it all depends on your reference angle. So wherever your reference angle is at, opposite's across from it. The hypotenuse is across from the right angle. And notice the hypotenuse is always there across from the right angle. Now what's adjacent? Adjacent to theta would be the one next to it. You can trace this angle to the right angle. That would be your adjacent side. Now, what if I decided to make theta here? Then yes, now this becomes the new adjacent side. And this would now be the opposite side if this was our angle theta. That's why we call this the reference angle, because it's in reference to the angle. Opposite and adjacent is always changing depending upon where the angle's at. Now, can the right angle be a reference angle? No. It cannot be a reference angle. The right angle cannot be a reference angle. Its opposite is hypotenuse. It's the other two angles that are going to be your reference angle. Last for this one, adjacent or opposite over adjacent is tangent. So across from theta is your opposite and next to it's adjacent. Once again, this flips around. If theta was here, now this becomes opposite and this becomes adjacent. So just think about that. Really get that down. Like I said, it's foundational going ahead. And by the time we get in pre-calc, you should have this down already. You saw an integrated 2, you saw an integrated 3, and you should be good at this already. You know, things are going to get a lot more complex from here. So sine of beta. So sine, if you remember, so that is so. So sine is opposite, which is 4 over hypotenuse. Notice the order matters there. So sine of beta equals 4 over 5. Simple. What about cosine of beta? So here's our reference angle, and I should be highlighting that. It's kind of obvious already. So cosine of beta, what is cosine? Well, cosine, if you remember from SOHCAHTOA, cosine is adjacent over hypotenuse. So adjacent is this side next to it. Now notice cosine is the function we're using. We're not saying ca of beta. Ca is just a little acronym for us to remember what cosine is. That's all that is. And so it's adjacent, which is 3, over hypotenuse, which is 5. So that will be your answer on this question. Really simple assignment. And last, tangent. So remember that's TOA. So tangent of beta. So looking at our reference angle, we want the opposite over the adjacent. And so that's going to be 3 over 4. And that's it.